In this next section, we're going to be taking a look at quadratic functions in standard form. And recall from the beginning of this unit that a quadratic in standard form is written as y equals ax squared plus bx plus c, or if you write it in function notation, f of x is equal to ax squared plus bx plus c, where a, b, c are constants and a cannot be 0. So let's take a look at why a can't be 0. We'll look at the first equation that we have written here, and we'll substitute in 0 for a. So we're going to get y is equal to 0 times x squared plus bx plus c. 0 times x squared is 0, and we are left with bx plus c. Now, if you recall from last year, when you have exponents on your variables that are 1, then you have a first degree equation, and first degree equations are linear functions. And a linear function is going to graph you a straight line, not a parabola. Quadratic functions draw or give you parabolas when you graph them. So if you take a look at this equation, your exponent on your y is 1, the exponent on this x is 2, and the exponent on this x is 1. To determine the degree of this equation, we would choose the highest degree, and so we say this is second degree. And second degree functions are called quadratics, and when you graph them, you get a parabola. Okay, so when a is 0, you no longer have a quadratic function, you have a linear function, and when you graph that, you will get a straight line. So in our first example, we're going to identify the characteristics of quadratics in standard form, and we're going to use a graph. In this case, we have this blue graph that we're going to take a look at for our first example. What we're going to determine is the direction of opening, the coordinates of the vertex, whether it's a maximum or minimum value, the equation of the axis of symmetry, the x-intercepts and y-intercept in the domain and range. Alright, so for this blue graph, it opens up. The coordinates of its vertex are 1 and -1. So in terms of this graph, because it opens up and it looks like a value, we have a minimum point, and our minimum point occurs when y is equal to -1. Okay, that's the lowest point on our graph. So when we talk about maximum or minimums, we're talking about what is the y-coordinate of our vertex. What is the lowest point on the graph? Or if it opens down, where is the highest point on our graph? What y-coordinate would give you that? Okay, so we get the maximum value or minimum value from our y-coordinate. Now, because we have a graph that opens up, we have a minimum. And the value of y when it's a minimum, we go to our vertex and we look at the y-coordinate, that's -1. Okay, so to know what our maximum and minimum points are of our parabolas, we look at the y-coordinate of the vertex. And this y value happens when x is 1, and we get that number once again from the vertex. Okay, our equation to the axis of symmetry, we go back to our vertex, look at the x-coordinate, it is 1, and so we write that x equals 1. We can draw that on the graph by drawing a vertical line that goes through the vertex. And don't forget to write the equation, x equals +1, okay, because it goes through where x is 1. Okay, our x-intercepts occur at, alright, our first one is right here. The coordinates for that point are at 0, 0. Our second one is here. The coordinates occur at 2, 0. And so our x-intercepts are at 0, 0. And 2, 0, and so have values of 0 and 2. Our y-intercepts occurs at, well, we go to our graph, we see that it crosses the y-axis at this x-intercept, and so we have an x-intercept and a y-intercept that share the same coordinates, 0, 0, and so we have a y-intercept that has a value of 0. So our domain, well, for all the parabolas that we're going to be taking a look at in this unit, our domain will be all real numbers, okay, and so we can write that using interval notation. So we go from infinity to infinity. Okay, and your range, well, if you have a minimum value of -1, that means that all of your y values will be greater than and equal to -1. And so we can write that using interval notation as going from -1 to infinity. Okay, and of course the other way you can write this is with set notation, where y is greater than and equal to -1, and y is an element of real numbers. Okay, on the next page we have an example which is similar to this one. Okay, so if you want to try it out on your own, then pause the video and come back to it when you're done and see how you did compared to what I will be doing. Okay, so in this example we have a parabola that opens down. The vertex of this particular graph, and you're going to have to kind of guess at this, but I know what it is. It's at 3 and -7. Okay, I know it's kind of hard to tell on this graph, but those are the coordinates for your vertex. Okay, and you know, when you get something like this and you don't have, you know, scale or tick marks on your x and y axis to help you out with your x and y coordinates, you're going to make a guess. Okay. Okay, so because this parabola looks like a mountain, we have a maximum point on the graph, which happens to occur when y, okay, we go to our graph, when y is -7. Okay, and you can get that from the y coordinate of your vertex. This y coordinate happens at the x coordinate for your maximum happens when y is -7, so that is at 3. We get that also from our vertex. Okay, axis of symmetry, go to your vertex, look at the x coordinate, and x is equal to 3. We can draw that by drawing a vertical line through the vertex and labeling it at x equals 3. Okay, x-intercepts occur at, well, if you take a look at our graph, the vertex is below the x-axis, which means that your parabola, and because your parabola opens down, it means that your parabola will not cross the x-axis, and because it won't cross the x-axis, there are no x-intercepts. So x-intercepts occur at, well, we're just going to put none because there are none, and has no values, so we will put none. But we do have a y-intercept. Our y-intercept is right here. Okay, and once again, you're going to have to make a guess at this, and it looks like it could be at -25. And so our y-intercept occurs at 0 and -25 and has a value of -25. Okay, our domain once again is all reals, and so we can use interval notation for that. And our range this time, okay, because we have a maximum value of -7, we have y values that are less than that. Okay, so our range goes from infinity to -7, or if you use set notation, you can write y such that y is less than or equal to -7, where y belongs to the set of real numbers. Okay, and that concludes example 1. In this next video clip, we're going to be taking a look at how to use your TI 83 or 84 as a graphing tool. This will be example number 2 from your 3.2 notes. The equation that we're going to be entering is y equals 3x squared plus 7x minus 6. So the first thing you'll want to do is to turn your calculator on. You'll be at the main screen. And we want to go into the y equals screen. So at the top or underneath your screen, there's 5 buttons across the top here. We're going to press the first one. That puts us into the y equals screen. And we're going to enter in under y1, so 3. And if you go down to the over to the second column of buttons, you want to go down to the third one, the one that reads x, t, theta, n. Press that. That will give you the x coordinate on your screen. We want to square x, so first column and 1, 2, 3, 4, 5, 6 buttons down, x squared, and then plus 7, back to your x, t, theta, n button, and that'll give you the x, and then minus 6. The next thing that we want to do is to set our window settings. So we go back to these menu buttons underneath the screen and we press window. Now what this allows you to do is to set up your x and y axis. Okay? So here's y, here's x. So on your x and y axis, your calculator is going to read to the left of 0 on the x axis as x min, to the right of the origin on the x-axis as x max, below the origin on the y-axis as y min, and above the origin on the y-axis as y max. Now I'm going to ask you to put in the following settings. If you can see on your handout, your x min is -10, so we'll leave that, because what you get when you first go into the window settings is the default settings. Okay, so we'll leave -10 and 10 and 1 the way it is. So -10 for your x min, 10 for your x max. The scale is 1, and then your y min. If you take a look on your handout, I would like you to put in -15. So you use the negative button here, and then 15. We're going to leave our x max at 10 and leave the scale at 1. Now what the x scale and the y scale allows you to do is to tell your calculator what you want to go up by. So do you want to go up by 1s? So then you put in an x scale and a y scale of 1. Do you want to go up by 2s, 3s, 4s, and so on? Okay? So what this window setting will give you on your screen once you graph is that you will have a x min at -10, so increments of 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, and -10. And along for your x max up to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your y min will go down to -15, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And a y max at 10, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so when you get to your graph, you should have x axis that goes from -10 to 10, and a y-axis that goes from -15 to 10. Alright, so the next step, if you go down, is to press graph, and you should have this on your screen. Okay, so we will now head on to the next part of the handout, which will be number 3. We're now going to be looking for the y-intercept, and if you can recall from previous years, y-intercepts happen when x equals 0. So here's our graph, and if you look at the instructions, we want to press trace. Okay, it shows you where the cursor is. Now, because y-intercepts happen when x equals 0, you want to enter x equals 0, so you want to press 0, on your keypad, and then enter, and it will tell you that your y-intercept is at -6. Okay, so we'll enter the coordinates over here. X-coordinate is 0, and y-coordinate is -6. Okay, so the next thing we want to take a look at is finding our vertex. When you're working with parabolas, usually you have to find a vertex. Okay, now there's two different vertexes that your calculator will recognize. One is maximum and one is minimum. A maximum vertex occurs when your parabola opens down. So here's an example of one that opens down. It looks like it's a mountain, and your maximum, of course, is the maximum point on the mountain, and in this case, it'll be your vertex. Okay. The second one is minimum. This is a parabola that opens up. You're looking for the lowest point. So this is a valley. The lowest point of your valley is considered a minimum. So when you go to your menu screen, right, when you press second trace, you're back at this menu here, okay, which is over here. And you're going to choose minimum in this case because we have a parabola that opens up, and so we have a minimum value. Okay, so we're going to press 3. Now, if you take a look at your screen, it says left bound ? Okay, so what does that mean? Well, let's take a look at figure 6. What I've done is taken the parabola and I've drawn a vertical line that goes straight through the vertex. This line that goes straight through the vertex is called the axis of symmetry, okay, and that's because it splits the vertex evenly into two equal parts that are mirror images of each other. To the left of that vertical line, I will call that region left bound, and to the right, I will call that region right bound. So what your calculator is asking for is for a left bound value of some sort. Okay, so what you want to do, you want to take your left arrow key here and you want to move the cursor so that it's to the left of the vertex. Okay, so it doesn't matter how far you go, just so long as it's to the left. Press enter and you'll get an arrow up here pointing to the right. Okay, notice your screen's now asking for right bound. So take your right arrow key, move to the right of your vertex, anywhere is fine, and press enter, and notice you have an arrow pointing to the left. Okay, so what these two arrows are telling you is that your vertex is in between those 2 points, or those 2 arrows. Okay, now your calculator says guess. Okay, so what it's going to do is guess a value for your vertex, so press enter, and here you have your minimum value of your vertex. It happens when x equals -1.17 to the nearest tenth, and when y is equal to -10.08 to the nearest tenth. Okay, so let's write that here. So to the nearest tenth, your x-coordinate is -1.17, and to the nearest tenth, your y-coordinate is -10.08. Okay, so what this tells you is that your lowest y value on your vertex, or on your parabola, is -10.08, and when that happens, x is equal to -1.7. Okay, so that's the coordinates of that point. All right, so now what we're going to take a look at is how to find your x-intercepts. Okay, now x-intercepts on this calculator is called 0, and your zeros just means x-intercepts, or from the past, remember the word roots. Okay, they all mean the same thing on the graph. Okay, they all mean find the x-intercepts. And the reason why your calculator calls it a 0, okay, is because x-intercepts happen when y is equal to 0. So what it's looking for is what is x when y is equal to 0. So once again, you need to be concerned with left bound and right bound. Since there are 2 x-intercepts for the following steps, it is best to choose your left and right boundaries so that it is an interval containing only one x-intercept at a time. So let's go to the next page and let's take a look at the diagram that I have. Okay, on the first one, figure 8, I have the left x-intercept highlighted with the cursor. I've drawn a vertical line through that, and on the left is left bound, on the right is right bound. Now, if you take a look, above the x-axis, the graph is left bound, okay, because to the left of your x-intercept, the graph is above the x-axis. To the right of your x-intercept, the graph is below the x-axis, so this bottom part here then is your right bound. Now compare that to when you're looking at the x-intercept, which is on the right. Okay, I've drawn a vertical line through it again, left bound and right bound. This time your left bound is the part of the graph which is below the x-axis. Okay, you can see the part below the x-axis to the left is to the left of the vertical line, and this time the right bound is above the x-axis because the part of the graph that you see to the right of the vertical line is above the x-axis. Okay, so let's take a look at finding the x-intercept, which is on the left of our parabola. So we're going to go second, trace. We have our menu. We're going to choose item 2 because that's a 0. And our x-intercept is right here. Okay, and go back to your drawing. We want to move the cursor above the x-axis. So use your left arrow key above the x-axis. See, your calculator is asking for left bound. Press enter, and here is your little arrow. Now we want right bound. Your calculator is asking for right bound, so take your right arrow key, move it below the x-axis, okay, because if you take a look on the diagram here, below the x-axis is right bound. Press enter again, and you get another little arrow here, tells you that your x-intercept is between those two arrows. Calculator asks you to guess, press enter, and you have an x-intercept at -3 and 0. Okay, so -3 and 0. Okay, so that is your x-intercept, which is to the left of your diagram. Now let's take a look at getting the one on the right. So we need to go back to our menu, so second trace. We want to choose 2 again. This time we want to find the x-intercept, which is on the right, so we want to move our arrow to our cursor, to the right of our vertex. And we want to make sure that it stays below the x-axis because left bound on this diagram is below the x-axis, and then we want to press enter. Got a little arrow asking for right bound now. Take your right arrow key, move it your cursor above the x-axis, okay, because that's right bound. Press enter. You have your 2 little arrows. Calculator is going to make a guess. Press enter again, and you have an x-intercept on your right, which is at 0.67 and 0. Okay, so let's write the coordinates in. 0.67 and 0. Okay, so the next thing that we are going to take a look at is how to find y when x is equal to 10. Okay, so what you want to do, you want to go back to your menu screen, so second, trace. You want to choose item 1, which is value. Okay, so press 1 on your keypad, and you should be at the screen here where it says x equals, and then your cursor is blinking. And because we want to find y when x is 10, we're going to punch in 10 onto our keypad, so 1, 0, and then enter, and you find that when x is equal to 10, y is equal to 364. Okay, so you go 364, and your ordered pair is 10 and 364. Okay, and the last thing that you will need to know how to do for any work that we're going to do after this is how to find x when y is equal to 5. Okay, so what you need to do with this, because this is an actual function. Okay, it's, if you recall from last year, a constant function. And when you graph it, it will give you a horizontal line. Okay, so you want to enter that into y equals. Bring your cursor down to y2. So use the down arrow key for that, and then put in 5 and graph. Okay, so what you see then is the same parabola you had before, but this time a horizontal line that's cutting through your parabola, which is other than your x-axis. Okay, so if we go to our diagram here, this line right here is y equals 5, and your parabola, of course, is y equals 3x squared plus 7x minus 6. Okay, so you've got two equations that are graphed on this graph now. Okay, and as you can see, when y is equal to 5, you've got 2 points on your parabola where y can be 5. Okay, wherever this line intersects your parabola, y is equal to 5. So we need to find what those points are. Okay, so what you want to do, go back to your menu screen again, so second trace, and this time we want to look for an intersection point between two lines, so that would be item 5 where it says intersect. So press 5, and it's asking for first curve, but what you want to do is you want to move the cursor to, and we're going to do the left one first, so we're going to move our cursor closer to the left, so we want to use the left arrow key and bring it up. You don't actually have to get on the line, you just have to be somewhere near it, so I'll show you like this. And then what you want to do is you want to press enter 3 times. Okay, so notice it has the question first curve, so press enter. Now it has second curve, so press enter again, then it's going to give you a guess, and you have a point of intersection which is at negative 3.41 and 5. Okay, now you would expect y to be equal to 5 because we're looking for x values when y is equal to 5. Okay, so we're going to get our second our second intersection point between the two lines. So we want to take our cursor, we first want to go to the menu screen, so second trace, choose 5 again, move the cursor to the right of the vertex this time, and get it somewhere close to your two lines. It doesn't have to be on or at the point of intersection. Okay, notice it says first curve, press enter. It's asking for second curve, press enter, and it's going to do a guess for you, press enter, and your second point of intersection is when x is equal to 1.08 and y is equal to 5. Okay, so you have 2 points of intersection, one at negative 3.41 and 5, and one at 1.08 and 5. Okay, but if you're asked find x when y is equal to 5, you can say that x is equal to negative 3.41 and x is equal to 1.08. Okay, so that concludes our discussion on how to use your TI 83 or 84 calculator. In this video, we're going to take a look at how to use your Casio graphing calculator. And this is the first year that I'm using it, so please bear with me in this video. I do believe that it's easier to use than the Texas Instrument, which is why I'm doing this. The graphing calculator that I'm using is the FX9960G USB. You may not have the same one, so I'm hoping that these instructions will be similar, if not the same, as the ones that you would use on your calculator. Okay, so to get started, I'm hoping that you will have already read the BLMs for this calculator, which I will have already put on Moodle for you. When you turn your calculator on, you will be in the main menu. Okay, so this will be on the screen. We want to choose graph, so use your down arrow key, your up and down arrow key, to move your cursor around. Put it over graph, okay, and press execute, and that will get you into this screen, okay, which is similar to the one over here. Now we want to enter in the equation 3x squared plus 7x minus 6. Now if you don't already have your graphing calculator in this screen, okay, say it's something else, then we need to reset the type. So you want to press F3 and choose the y equals here, so F1, and that will make sure that you're in this screen, okay? Okay, so let's enter in 3x squared plus 7x minus 6. So we type in 3. We're going to go to this button over here, which is on the left, the x theta t button. That will put an x coordinate on your screen. And then press your x squared button. That will square your x. We want plus 7 back to your x theta t button, and then minus 6, and hit execute. Okay? And your screen should look like this now. Okay, the next thing we want to do is we want to enter a window and then graph the function. Okay, so we're going to set our window settings. So you need to press Shift F3, and that will put you in this window. Now, what you have here is the default window settings, but they're not adequate for this particular graph. Okay. Now, if you take a look, you have X min, max, scale, and dot, and then you'll have the same items underneath Y. You'll have Y min, max, scale, and dot. Okay. Now, I just want to talk a little bit about that before we set our window settings. Okay. So when you go to graph on a coordinate system, you will have an x and a y axis. Your x min is on the negative part of the x-axis, which is to the left of 0. Okay, and your x max is on the positive x-axis, which is to the right of 0. Your y max will be above the 0, so the positive part of your y-axis, and your y min will be below 0, which is the negative part of your y-axis. Okay. So what we want to do for this particular graph is we want to set our x minimum at -10. So we're going to type in -10. So you go to your negative button, which is at the very bottom of your keypad, and then punch in 10. Use your down arrow. Oh, sorry, execute first. Then you're going to type in, I would like you to have an x max of 10, so type in 10. Execute. We're going to leave our scale at 1. Okay, what that means is that our x-axis will go up by 1, so 1, 2, 3, 4, 5. If you put in a scale of 2, it would go up by 2, so 2, 4, 6, 8, 10, and so on. Okay, and don't worry about the dot. I think it just probably has something to do with well, I guess the dots on your screen. I'm not 100% sure. Okay. So now we want to go down to our y min. So now we go down arrow. Okay. And I would like your y min to be at -15. So type in -15, execute, then type in +10. Okay, and execute. And we're going to leave our scale at 1. And so execute. And that brings us back to our y equals screen. Okay, so what we've done then is for our x-axis we have gone from -10 to 10. Our scale is 1, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And on our y-axis we went from 10 to -15. Okay, so on your graph then, you now want to press F6. Notice it says draw above that. Press F6 and you should have this on your screen, which will look like figure 3. Okay. All right, so we have now entered in a window setting and we've graphed. We're now going to go to the next page and we're going to find our y-intercept first. Okay, and what I really like about this calculator is that finding y and x-intercepts is a lot easier. Okay, so to find your y-intercept, you want to press Shift F5 and then F4. Okay, so we're going to go Shift. We choose F5 because you notice it says G-solve. Okay, so we want to solve our graph. So press S5. And then you have some items along here with an arrow key here to show more items once you press F6. Okay, now we want our y-intercept. So notice y-intercept is right here, that you would press F4 for that. And there it is. There's your y-intercept. Okay, your y-intercept is at -6. And notice that the ordered pair for that is given on your screen also. X is 0, y is -6. Okay, so your y-intercept is at -6. The coordinates for that point are 0 and -6. Okay, so next we're going to find our x-intercepts. Okay, and so we're going to shift F5 again, so Shift F5 for the G-solve, and this time we want our x-intercepts. Now your x-intercepts are your roots, okay? So on this calculator it says root, so you press F1, and there you go, you get one of your x-intercepts at -3 and 0. But notice your parabola crosses the x-axis twice, so you have an x-intercept on the left, you also have one on the right. So to get the one on the right, all you do is you hit your right arrow key and it will give you the one on the right. Okay, so the x-intercept on the left is at -3 and the one at the right is at 0.67. We'll round to the nearest tenth. Okay, all right, so let's enter that information in on our handout. Okay, so we have one x-intercept at 0.67 and the other one at -3. So we have so the ordered pairs would be 0.67 and 0 and -3 and 0. Okay, so let's move on to finding the vertex. Now on your graphing calculator, you will have two choices, a maximum or a minimum. Okay, if you have a maximum, okay, that means that your parabola will open down. Okay, it'll look like this. It'll look like a mountain. And what you're looking for is the maximum point on your parabola, so the highest point on the mountain. Okay, and the other one is a minimum. Okay, that means that your parabola opens up. It looks like a valley, and you're looking for the lowest point in the valley or the minimum point of your vertex. Okay, so let's get our graphing calculator. We want to press Shift F5. Okay, Shift and F5 again because we still want the graphing calculator solver. Okay, and here are your two choices, maximum and minimum. This particular parabola opens up, so we're looking for a minimum, so we press F2 for minimum. Sorry, F3 for a minimum. Okay, and voila, there it is. Okay, you have a vertex which is at -1.17 and -10.08. So this information tells you that the lowest point on your parabola happens when y is equal to -10.08. When y is -10.08, x is -1.17. Okay, so let's enter that on your handout. So your x coordinate is -1.17 and your y coordinate is -10.08. Okay, so let's take a look at our last two items. On item number 6, we want to find what y is when x equals 10. Okay, so we want to press F5 again. Wait a second, I think we want to go Shift F5. Sorry, we want to go Shift F5. Okay, and we're going to do the same thing on this one here. Sorry, should have put that in there. All right. Okay, so we're going to go Shift F5. We've got that. Now, we want to find y when x equals 10. Okay? So press F6 because we want more items on our list. And you can see that we have a y calc and an x calc. Now, we want to find y, so we want the y calc. So press F1. So what x value do we want to type in? We want to type in 10. And then you want to execute. And so you find that when x is 10, y is 364. Okay. So when x is 10, y is 364. The ordered pair for that is 10 and 364. Okay, let's go to item 7. This time we want to find x when y equals 5. So we want to go Shift F5. We want F6 because we want more items on our menu. And we want to find x, so we're looking for x calc, so we press F2. And we want to press type in 5 because we want to find out what x is when y is 5. Okay, and execute. All right. Now, with a parabola, there's going to be two y values for this. Okay. So our first one happens when x is equal to negative 3.41. To get the second one, we just hit our right arrow key, and that brings us to the second one. See, we still have y equals 5, but this time it happens when x is equal to 1.08. Okay, so we've got two x values when y is equal to 5. Okay, one at negative 3.4 and one at 1.08. All right, so let's enter that in on our handout. So y, when x equals 5, y can equal negative 3.41, and it can equal 1.08. So our ordered pairs for that would be negative 3.41 and 5, and 1.08 and 5. Okay, so that concludes our discussion on how to use your Casio graphing calculator. We're going to do example 3 on our graphing calculator. And if you go to your notes for section 3.2, example number 3, we're looking at an application problem where we're looking at a frog jumping into a pond. So the question goes, a frog sitting on a rock jumps into a pond. The height, h, in centimeters of the frog above the surface of the water as a function of time, t, in seconds, since it jumped, can be modeled by the function h of t equals negative 490 t squared plus 150 t plus 25. Where appropriate, answer the following questions to the nearest tenth. And then there's a series of questions on your handout. Okay, so here's your function. Okay, h of t equals negative 490 t squared plus 150 t plus 25. In your graphing calculator, the variable h is going to be y. Okay, so this is going to be your height, and your height will be in centimeters. Your t coordinate in your formula is going to be your x in your graphing calculator, and the t is time in seconds. Okay, so we're going to start by entering that into our graphing calculator. So we're going to press the y equals button, and we first have to make sure that our calculator is on, and we're going to go to y equals, and I've entered it in already. Okay, so negative 490 x squared plus 150x plus 25. Now, with these application problems, you will be expected to put in window settings. And for step number 2 on here, I have one way for you to do it. Usually I do a guess. Okay, so I'm going to start with that. And you can read this section over on your own if you find that the guess method isn't going to work for you. Okay, now when I say guess, I mean making an educated guess. Okay, and so I go back to my formula. Okay, and I'm going to replace h of t with h, and I'll just rewrite it here. And I'm going to determine what my y-intercept is. Okay, now my y-intercept happens when t, or x, okay, is 0, and in this case my x will be t. So when I substitute in 0 for t, then I'm going to get 0 plus 0 and plus 25. So I find that my height is 25. What this 25 means is that your frog has a starting height at 25 centimeters. Okay? And so what you need to think about is, how high do I think my frog is going to jump? Okay? And it's probably not going to be, you know, like 3 or 4 meters. It's probably going to be less than that. So I'm going to say, well, you know what? If my frog starts jumping at 25 centimeters, maybe he'll reach a height of 50 centimeters. So for my y max, I'm going to start by putting in 50. Okay, so this is going to be what I think might be the maximum height. Okay, and you'll see as we work through the problem that it won't be 50, but it's a good starting guess. Okay, so keep in mind your x coordinates are the time and your y coordinates are the height. We're going to start at 0 seconds, so for your x min, put in 0. For your x max, think about how long it's going to take for the frog to enter into the water, you know, from the time that it starts to jump to when it's going to hit the water. I'm going to estimate no more than 1 second. Okay, and this will be my time to reach the water. Okay, and as you're going to see as we go through the problem, it won't be 1 second, but it will be pretty close to that. Okay. All right, now on my x-axis, I want to see some tick marks, so I put my scale in at 0.5. You can make it 0.1, 0.2, 0.3, whatever you want. I'm just going to say 0.5. And because my max height is at 50, I'm going to put a scale in of 10. Okay, so that will be my next step. I'm going to put in 0 for my time. I'm going to put in a maximum of 1 second. My scale will be 0.5. And I'm going to leave my y min at -10 because you're going to find that when you're working on the calculator, you're going to have some writing down at the bottom. And I don't want it to interfere with my graph, so I'm going to put it down at -10 so that my writing doesn't get in the way of the work that I'm doing. Okay, all right, and my y max I'm going to put at 50 and my scale at 10 and then graph. Okay, and it should look like the picture that you have on the right of your page here. Okay, so now we're going to, and this is a good picture. Okay, you can pretty much see the whole parabola. The only part that's missing is the part that goes beyond, you know, the x-axis at the negative part, but we're not interested in what's negative on my graph because in real life your numbers are always positive. Okay, so we don't need to worry about what's to the left of the origin here, and so this is a good picture. Okay, so our first question is to find the height from which the frog jumps. Okay, well, the height that the frog jumps from is going to be your y-intercept. Okay, so the height from which the frog jumps is the y-intercept. So we're going to find our y-intercept. Okay, and if you remember, you press trace, And oops, turn my calculator on, press trace. And I need to have where x is equal to 0. Right now it's at 0.5. Okay, so I'm going to press 0 and then enter, and I get a y-intercept, which is at 0 and 25. Okay, now remember the x-coordinate is t, the y-coordinate is h. We're looking for a maximum height, and so the maximum height that the frog jumps is 25. Sorry, we're not looking for maximum height. We're looking at the height from which the frog jumps. So the height from which the frog jumps is 25 centimeters. Okay, and notice that the time is 0, so this is our starting point. Okay, find the maximum, because we want to know how high does the frog jump. Okay, so what we're going to look for then, because words like maximum and minimum should suggest to you vertex, we're going to look for the vertex. Okay, and the vertex will give the maximum height and the time that it takes to reach that height. The vertex in your calculator is at x and y, but the vertex in the problem, okay, is t and h. So let's get our vertex. We're going to go second trace. We have a maximum, so we're going to choose 4. So type in 4. And we need to do a left bound and a right bound. Okay, notice it says left bound, so I'm just going to move my cursor a little bit closer to my vertex. It's still to the left of my vertex. I'm going to press enter, move my cursor to the right of my vertex, press enter. I've got 2 arrows here, so my vertex is in between those 2 arrows. It asks me to guess, so I'm going to press enter again, and I get a vertex, which is at, to the nearest tenth, 0.2 and 36.5. Okay, so remember this is t, this is h, so the frog jumps to a maximum height of 36.5 centimeters. It takes 0.2 seconds to reach that height. Okay, and we're answering that question because in your handout it says it asks you to figure out the maximum height and then when it reaches that height, and so it reaches that height at 0.2 seconds. Okay, so let's move to the next page. When does the frog hit the water? Okay, well that means that we are going to look for an x-intercept. Okay, so we want the value of x when y equals 0. And so the x-intercept gives the time at which the frog hits the water. Okay, and if you take a look at the graph that we have, the x-intercept is over on the right. We know that there's one to the left of the origin on our x-axis, but we don't need to concern ourselves with that because that's going to give us a negative number and we're only concerned with positive numbers. Okay, so getting x-intercepts means you need to find your zeros. So you're going to go second trace, choose item 2. You're asked to do a left bound and a right bound, so we want to bring the cursor closer to our x-intercept. And if you notice, left bound in this case is going to be above the x-axis. So left bound, hit enter. We want right bound, we're going to go below the x-axis. So we're below the x-axis now, enter. Here are two little arrows. We need to make a guess. Our x-intercept is in between those two arrows. Enter, and we get an x-intercept at 0.4 and 0 for a height. Okay, so what this means is that the frog takes 0.4 seconds to hit the water, and the height, of course, at that point is 0. Okay, so the frog hits the water at 0.4 seconds. Okay, now in your handout, they also ask for the domain and range at this point. Okay, so let's take a look at our domain. We're going to use set notation. So t such that. Okay, so remember your x coordinate is time, so we're looking at t. And your domain can only go from where x is 0 over to where the frog hits the water, which is right here, so 0.4 seconds. Okay, so our domain is between 0 and 0.4. Okay, our range is the h coordinate. Okay, and our range is going to go from 0, okay, up to our maximum height, whatever our maximum height is. It'll be in between there. Okay, so it will go from 0 to our height, maximum height, which was 36.5 centimeters. Okay, and where h belongs to the set of real numbers. Okay, so there's your domain and your range. Okay, the next question is asking you to determine how high the frog is after 0.25 seconds. Okay, and so what you want to do then, because seconds is our time, then we're really concerned with our x coordinate. So what we want to do is we want to type in that x is 0.25 seconds and find out what y is at that time. Okay, so the way to do that, you want to go to second, trace, you want to choose value, so that's item 1, so press 1, put in for x 0.25 and press enter, and you find that at 0.25 seconds, so I'm going to write that as an ordered pair, so at 0.25 seconds the frog will be 31.9 centimeters off the water. Okay, that's how high they will be. So the frog will be 31.9 centimeters high after 0.25 seconds. Okay, and I'm adding one more question. I know it's not in your notes and you're not asked to do it, but it'll show up on a test or a quiz. For how long is the frog above 26 centimeters? Okay, well, 26 centimeters, as you know, is a height, which means that you're concerned with your h coordinate, and as far as your graphing calculator is concerned, your h coordinate is y. So we are going to enter that in where y, at the y equals window. We're going to enter it in as y2. We want to put in 26 centimeters, and we want to graph, and we should get a line across the top. Okay, so this line here is your y equals 26 centimeters. So I'm going to write that on here. So y equals 26 centimeters, and this is y2. Okay. All right, so what we want to know is, what are our points of intersection? What is this point right here on our graph, and what is this point here? So we're looking for 2 points of intersection. Okay, so we're going to go second, trace. We are going to choose item 5 for intersect, and we are going to bring the cursor up, and I'll do the one on the right first because my cursor is closest to that. Okay, notice it says first curve, press enter, second curve, press enter, guess, press enter, and so your first point has the coordinates of 0.3 and 26, okay? Which you would expect the y to be 26 because that's what the y coordinate is for this line, okay? As a matter of fact, the equation for this line is y equals 26. Okay, now we're going to do this again. So second trace, item 5, bring the cursor to the other side of the vertex, closer to the second, the second intersection point that we're going to take a look at. It says first curve, enter, second curve, enter, guess, enter, and your second point of intersection is, and I'm going to round our x-coordinate off to the nearest hundredth, so 0.01 and 26. Okay, so we go back to the question. The frog is above 26 centimeters between the times of 0.01 seconds and 0.3 seconds. Subtract your two times. Take the smallest number from the biggest number. And the object is above 26 centimeters for 0.29 seconds. Okay, now in your notes you were also asked to do number 7 on this handout algebraically. So we're going to go back to our notes. Okay, and we're going to answer that question right here. Okay, so our function is h of t is equal to negative 490t squared plus 150t plus 25. Okay, and you want to answer part F algebraically. So how high is the frog? 0.25 seconds after the jump. Well, 0.25 second is your number that you will plug in for your t variables. So h of 0.25 is equal to negative 490 times 0.25 squared plus 150 times 0.25 plus 25. And when you do all that math on your calculator, you will get 31.875. And so the frog is 31.9 centimeters high after 0.25 seconds. Okay, and if you compare that to what we did on the graphing calculator, you will have exactly the same number. All right, that is the conclusion to example 3. This next example, example 3, we are going to be doing in our graphing calculators, using our graphing calculators. And this is the frog question, which is in your notes on section 3.2, and it reads as follows. A frog sitting on a rock jumps into a pond. The height h in centimeters of the frog above the surface of the water as a function of time, t in seconds, since it jumped, can be modeled by the function h of t equals negative 490t squared plus 150t plus 25. Where appropriate, answer the following questions to the nearest tenth, and then you have a series of questions that you need to answer. So here's our function, h of t equals negative 490t squared plus 150t plus 25. Your h coordinate in this formula is your y coordinate in the graphing calculator. Okay, and the t coordinate is going to be your x coordinate in the graphing calculator. That means that all coordinates on the graph that you will graph in your graphing calculator will have coordinates of t and h. Okay? All right, so we're going to start by entering our our equation into the graphing calculator. Okay? Now, if you find that you don't have, I'll just exit from here just to show you. If you find that you're not in the y equals screen, then you want to make sure that you are. So you want to go to type, which is F3, and then you want to choose y equals, which is F1, and will put you into that screen. Okay, so we want to enter in our equation. So negative 490 x squared plus 150 x plus 25. Okay, and then execute. So there is your equation into your graphing calculator. And the next thing that we want to do is to set our window functions. Okay. Actually, I'll just minimize that for a sec. Okay, so how do we decide what our window settings are going to be? Okay, if you take a look at the function, which is h of t equals negative 490 t squared plus 150 t plus 25. And we want to start setting our values for our x and our y axis. So here's our x-axis, and here is our y-axis. Okay, so what we want to know is to what value are we going to put in as a maximum for our x coordinate, our x-axis, and what's going to be our maximum for our y. Well, one way to approach the problem is to find out what your y-intercept is. Okay, so we can get a maximum value anyway. Okay, so we'll start with our y-max. And I'm going to plug in, first of all, and find out what my y-intercept is, because I can kind of guess what a y-max might be based on my y-intercept. So I'm going to find my y-intercept, which is where t equals 0. And I'm going to plug that in. And I get that h of 0 is equal to 0 plus 0 plus 25, so 25. Okay, so what this tells me is that my y-intercept is 25. Now we have a frog jumping into a pond. This represents 25 centimeters. The question is, how high is this frog going to jump? It's probably not going to be a meter. It's probably not going to be 2 meters. It's probably going to be less than a meter. So I'm going to make my first guess that my y-max is going to be around 50. Okay, and this is just a guess. You're going to find that the maximum height really isn't 50. It's actually below that. So this is a pretty good number to put in for your y-max. Okay, now remember, your x coordinate is for time, and your y coordinate is for height. Okay, so for my time, my x min, I'm going to put at 0. I don't need to know a time which is less than 0 seconds. Okay, so what I need to think about is, if my frog jumps off this rock, how long do you think it might be before it hits the water? So my guess is maybe 1 second. So this is going to be when the frog hits the water. And once again, it's just a guess. We're going to find from our work that it's actually less than that. So for my x-axis, I'm going to start at 0. I'm going to go as high as 1. And I do want some tick marks on my x-axis. So I'm going to put in a scale of 0.5. So if this is 0, this is 0.5, and this is 1. Okay? And we've already decided our y-max is going to be around 50. And I want to put in negative 10 as my y-min, because there's going to be writing at the bottom of the screen here, and I don't want it to interfere with my x-axis, so I'm going to start at negative 10. And something that you can't see on this diagram here is that I'm putting in a scale of 10 for my y-axis. Okay, that means I'm going to go up by 10. So 10, 20, 30, 40, 50. So this point here is 50. Okay, so let's get our calculator back. We want to go Shift F3. We're going to enter in 0 for our x min, so 0, execute. Our x max we're going to put in as 1, execute. My scale is going to be 0.5, execute. Down arrow, negative 10 for my y min, execute. And my y max I'm going to put in as 50, execute, and my scale I'm going to make 10 execute, and then exit. And we want to draw the graph now, so press F6, and here is your graph. It should match the picture in the diagram that I have on your handout. Okay. All right, so we're going to go to the next page and start answering the questions that you have been asked. Okay, so the first question you are asked to do is to determine the height from which the frog jumps. Well, the height from which the frog jumps is right here on your screen. It looks like it's a y-intercept. So your y-intercept gives the height from which the frog jumps. Okay, so let's get our calculator out. We want a y-intercept. We're going to go Shift G-solve F5. We want y-intercept, so F4, and we get a y-intercept which is at 0 and 25. Okay, so y-intercept 0 and 25. Remember, your coordinates are t and h. So according to your y-intercept, when the time is 0, the height is 25, so that's the starting point from which your frog jumps. So the frog jumps from a height of 25 centimeters. Okay, next question. How high does the frog jump? Well, when you're looking at how high or how low something is, we're looking at maximum and minimums because we want to know how high. And we can clearly see that our parabola opens down and we have a maximum point. That means we are looking for the vertex. So the vertex gives the maximum height and how long it takes to reach the maximum height. Okay. In the graphing calculator, the coordinates of the vertex are x and y. For this problem, we interpret the coordinates of the vertex to be th, where x coordinate is the time and the y coordinate is the height. Okay, so let's get our calculator, and this time we want to find a maximum, so we want to go Shift F5. We want a maximum of F2, and you can see that our maximum then has coordinates of 0.2 and 36.5. Okay, so this means that the frog reaches a height of 36.5 centimeters after 0.2 seconds. Okay, so when it reaches a height of 36.5 centimeters, it takes 0.2 seconds to reach that height. Okay, the next question is asking you, when does the frog hit the water? Well, if this parabola traces the path of the frog, then it looks like it will hit the water on the x-axis. So what we're looking for then is an x-intercept. So the x-intercept gives the time at which the frog hits the water. Okay, so let's work out how to get our x-intercept. You want to go Shift F5 for G-solve. We want root this time. Remember, your x-intercepts are your roots, so F1. And you can see that our x-intercept is at 0.4 and 0. Okay, remember this is t and h. So when the time is 0.4 seconds, the height is 0. So height is 0 when the frog hits the water. So the frog hits the water at 0.4 seconds. Okay, now on your handout it asks you at this point to determine what the domain and range of this function are. So the domain, remember, is your t variable. So we want to know from what time to what time this graph represents. In terms of our problem, well, the frog starts at a time of 0 and hits the water at a time of 0.4 seconds. Okay, so here's your domain and set notation, your range. Well, the height at which, according to our graph here, the height at which the frog hits the water is at 0 centimeters, so that's right here. Okay, so 0 centimeters. And the maximum height that our frog reaches is 36.5 centimeters. So our range goes from 0 to, so we're going to go h from 0 to 36.5, and h belongs to the set of real numbers. So here is your range in set notation. Okay, next question. In this next question, you're asked to determine how high the frog is after 0.25 seconds. So this represents time, and in your graphing calculator, that's your x variable. So what the question is telling you is when x is 0.25, what is the value of y? Okay, so let's get our calculator out, and we're going to go Shift F5. We want more options, so F6, and we want to calculate the value of y when x is 0.25, so we want y calc. And we're going to plug in 0.25 for x, and we're going to execute, and we can see that our coordinates for this point on the graph is at 0.25 and 31.9. So we have coordinates at 0.25 and 31.9. That means that the frog is 31.9 centimeters after 0.25 seconds. Next question. We want to determine how long the frog is above 26 centimeters. Okay, now I know this is not on the actual list of questions that you're given for example 3, but it will show up on a quiz or a test, so we're going to work it out on this problem. So 26 centimeters is the height. Okay, that's the y variable. They're saying if y is 26, then what is x? In this question, it would be h is 26, then what is t? Okay, so you get out your calculator. We're going to go Shift F5. We want more options. We are given h or y in this case, so we want to find x. We want x calc, so F2, and put in 26, execute, and here's your first point. Now, this number 6.8185 e negative 3, okay, means that you have a number here in scientific notation, okay? It's 0.0068185 times 10 to the negative 3 when y is equal to 26. Okay? Now, that tells you what the time is the first time the frog reaches a height of 26. The second time that the frog reaches a height of 26 is over here, so we want to know what that time is too. So we hit our right arrow, and the next time our frog reaches a height of 26 centimeters is at 0.3 centimeters. Okay? All right, so I'm just going to write down here that this number means 6.8 times 10 to the negative 3, which written as a decimal is 0.006. And for the purposes of this problem, I am going to round it off to the nearest hundredth. So the frog is above 26 centimeters between the times of 0.01 seconds and 0.3 seconds. We want to know what time the frog is above 26 centimeters, so we need to subtract our two numbers, so 0.3 minus 0.01, and we get 0.29. And so the frog is above 26 centimeters for 0.29 seconds. Okay, the last thing that we need to do on example number 3 is to take this question here, number 6, and work it out algebraically. So we're going to go back to our notes. And I have it written out here, so I'll just go over it with you. Okay, so we want to know how high the frog is after 0.25 seconds. The 0.25 seconds represents t in the formula. Here's your formula. H of t is equal to negative 490 t squared plus 150 t plus 25. We want to plug in 0.25 for t, so wherever there's a t, I'm going to plug in 0.25. So h of 0.25 equals negative 490 times 0.25 squared plus 150 times 0.25 plus 25. Plug all of that into your calculator and you will get 31.875, and so the frog is 31.9 centimeters high after 0.25 seconds. Okay, and if we go back to our work with our graphing calculator, you can see that you get exactly the same number. Okay, that concludes this example number 3. In this next problem, we're going to be taking a look at maximum and minimum problems, and in this particular case of a quadratic function. Our first question is we're going to take a look at a rectangular lot that is bound on one side by a river and on the other 3 sides by a total of 80 meters of fencing. You are asked to find the dimensions of the largest possible lot. So when we consider the word dimensions, we consider the length and the width. When we consider the largest possible lot, we are considering the area. So before we get started on working out the problem, we have a tip. See what you want to maximize. And in our question, because we want the largest possible lot, we want to maximize the area. Then we're going to let that be the main equation. Secondly, have a supporting equation. In our case, perimeter, because if you go back to the problem, you know that this rectangular lot has 3 sides that would use up a total of 80 meters of fencing. So you know that the 3 sides to your lot total 80 meters of fencing. So here's a diagram. Here's your river. Here are the 3 sides of your lot. You know that these 3 sides use up 80 meters of fencing. We're first going to start on the supporting equation. So when you work on these kinds of questions, first deal with the supporting equation and then we deal with the main equation. Now our supporting equation for this will be perimeter, like I said earlier. And if you take a look at your picture, you don't have a full rectangle, okay, because one side is bound by the river. So what you have is you've got this side which is considered a width, this side which is considered a width, and this side which is considered a length. So if I want the perimeter for these 80 meters of fencing, then I've got 2W and 1L. So the perimeter formula then will be 2W plus L. Now I do know what the value of my perimeter is because I know how much fencing I have. My perimeter is 80, so I will plug that in for P, and I get 80 equals 2W plus L. Now we want to isolate one of the variables in this little formula. Okay, the easiest one to isolate will be L. There's no coefficient in front of it, So it's very straightforward. All I have to do is move the 2w over to the other side of the equation to the left, and it becomes negative. And so I get that the length is equal to 80 minus 2w. Now, this is important because in our next step, we are going to write some let statements. Okay? And what your supporting equation does is give you an algebraic expression for one of your dimensions on your rectangular lot. And as you can see in this particular example, we are going to have an expression for the length. So we're going to let L be 80 minus 2w. So that tells us that this side, okay, the longest side of our rectangular lot, is going to be the 80 minus 2w. The other two sides, we're just going to use our variable w. So we're going to let w be the width. Okay, and L in this case, of course, meaning the length. Okay, so now we're going to take a look at our main equation. Because this is a rectangular lot, the area to a rectangle is length times width. I don't know what the area is, so I can't substitute anything in for that, so I will leave it as A. The length, I'm going to use the expression 80 minus 2w. And of course the width will just be w. When you write this equation, whatever's on the right-hand side of the equal sign should have only one variable. You shouldn't represent it using two variables, okay? So when we come over here, what's important is that you have expressed the length using w as your variable, okay? So you need to be able to express both your width and your length using one variable only. All right, and the next step is we are going to expand, so we're going to distribute the w, and we're going to write it in standard form. All right, that means we're going to write it in the form of y is equal to ax squared plus bx plus c. So that means that our x squared term goes first. So I'm going to go w times negative 2w, and that's going to give me negative 2w squared. And then w times 80, which gives me 80w. Now if you compare what we have for our area to the standard form of our quadratic, notice that we don't have a constant term on our area formula, okay? And that's all right. Okay, if you go back to what we did at the beginning, the only thing that we really need in order to have a quadratic is that we have a squared term, and we do. We have a w squared term here. So we know that this will be a parabola when we draw it. Okay, so this is our quadratic function. Okay, so our next step then, we do want to determine what the dimensions are of our parabola. Okay, and what's going to help us is finding the vertex. And then once we find it, we're just going to take a look at what it represents. So I'm going to introduce you to the vertex formula. It is x is equal to negative b over 2a. You don't need to memorize this because I will put it on a formula sheet for you, but it doesn't hurt to. It's just a small formula. It would be a lot easier just to remember it and take it out of your head instead of going to a piece of paper to find it. Okay? Okay, so what our vertex formula does is it gives us the x coordinate of the vertex. So our vertex for this particular problem, if you take a look at our formula up here, we've got area equals negative 2w squared plus 80w. The a part of the function is going to be our y coordinate, and the w is going to be the x coordinate. So when we go to get our vertex, it's going to be in the form of w and A. Okay? So what our vertex formula does here is it gives us the x-coordinate of whatever our vertex is. Okay? In this case, it's going to be W. So I can plug W in for that. And go back to your formula here. Your A value is -2. So I will write that down here. And your B constant is 80. So we're going to plug those numbers into our formula. So the width is going to be equal to -b, so -80, over 2 times A, so in our case 2 times -2. So when we simplify, we're going to get -80 over -4, and so W is equal to 20. So that tells us that the width of our rectangular lot is 20 meters. Now what we want to do is to get the second coordinate of our vertex, which is our area. So how do we do that? Well, we go back to our formula. Area is equal to -2W squared plus 80W. And because I know what W is, I can just substitute that value into W into my formula, and that will give me A when I simplify. So area is equal to -2 times 20 squared plus 80 times 20. And so the area is equal to 800. Okay, so we have the width. We have the area. And if we go back to our problem, we need to determine what the dimensions are. So we need the length and the width. And right now we only have the width. Okay, so how do we get the length? Well, we're going to go back to our supporting equation, and notice we have an expression for the length. We know that the length is 80 minus 2W. So that's what we're going to use to determine what the length is. So the length is equal to 80 minus 2W. I know that W is 20, so I'm going to substitute that in for the W in the formula. And then I'm going to simplify, so I get 80 minus 40, which is 40. And now I have the length. Now, if I want to do a quick check to see if my dimensions are correct, I can just plug that into the area formula. According to what we've worked out, my area is going to be 20 times 40, right? Length times width, and that gives me 800. Okay, and if you take a look, that's what we have here. Okay, that our area is going to be 800. So my vertex then is my width first, so 20, and my area second. Okay, so your vertex is 20, 800. And so the maximum area is 800 meters squared, and the dimensions are 20 meters for the width and 40 meters for the length. Okay, and the second part of the question was, what does the vertex represent in this situation? So what our vertex tells us is that when the width is 20 meters, the maximum area is 800 meters squared. Okay, so the vertex represents the width for a maximum area. Okay, so in terms of our problem, when our width is 20 meters, we get a maximum area of 800 meters squared. So the next part of our question is asking us to graph the function that we got in the first part of the question, and we're going to use our graphing calculator to do that. So I'm going to use the TI-83. Okay, and what I've done already is plug my formula in. Okay, so the negative 2x squared plus 80x. And I've set my window settings. Okay, if we go to the graph here, you can see that we're going to have a x value which will be 0 and a y value which will be 0. Okay, so our x min will be 0 and our y min is going to be 0. Now, how do you decide what you're going to plug in for your x max? Well, if you take a look at the problem, our x coordinate is the width. And if you take a look at what we got for our widths that would give us a maximum area, we have 20 and 40. So we know that our x max has to be at least 40. What I did was I plugged in 50 for my x max because I want to have a good picture, so I need to add at least a little bit more onto the 40 so that when I get the graph of the parabola on the screen, it will fit nicely in the screen. Because I chose an x max of 50, I went ahead and used a x scale of 10, so we're going to go up by 10s. Now, I know that according to our graph over here, we're going to have a y min of 0, but I'm going to put it at negative 10 because we're going to have writing at the bottom of the screen, and I don't want it to get in the way of the graph that will be on the screen. So I'm going to put a negative 10. Now, my y max, we already know that the maximum area for our lot is going to be 800. So we have to have at least 800 in our y max, but I'm going to choose a little bit of a higher number just so that it'll look nice on the screen. So I'm going to pick 900, and I'm going to go up by hundreds. Okay, so on the y-axis we'll be going up by 100s, and then we're going to graph. And so here's your picture. Okay, so along the x-axis then, which is our width, I'm going to go up by 10, so 10, 20, 30, 40, 50. And I'm going to go up by 10s on the y-axis, which is our area. So 100, 200, 300, 400, 500, 600, 700, 800, 900. Okay, oh sorry, so I'm going to go up by hundreds on my y-axis. Okay, now in order to graph this, we will need some points. Okay, minimum for graphing a parabola would be x-intercepts if there are any. Y-intercept if there is, well, there will be one, so y-intercept, and your vertex. Okay, so if you're going to use your graphing calculator to graph a quadratic function, those are the minimum points that you should have on your graph. Okay, so let's take a look at our x-intercepts. I'm going to go and find those first. I want to choose 2 on the screen because I want my zeros. And bring my cursor over. And do my left bound. And then bring it up to do my right bound, and then guess. Okay, so we have an x-intercept at 0 and 0, so that's 1 point. And let's do this in blue. Okay, so I have a point here at 0 and 0. And now I'm going to go take a look and find my second x-intercept. So I'm going to bring the cursor over to the other side of the vertex. Okay, here's my left bound. Go below the x-axis, here's my right bound, and enter. And I get an x-intercept at 40 and 0. Okay, so that would be right here. Now note that your x-intercept and your y-intercept are the same value, okay, because at this point the graph will go through both the x and the y-axis. Okay, so x-intercept here and y-intercept are the same point. Okay, our next point is the vertex. We already know that it's going to be at 20 and 800, but we can verify that on our calculator. So I'm going to go to second trace. Now we have a maximum because we have a parabola that opens down, so I'm going to choose item 4. And I'm going to do the left bound, right bound again. Okay, enter, left bound. Enter and enter again. And we have, as you can see, a maximum at 28 and 800. So this is one way that you can verify your work also. Okay, so 20 is right here, 800 is right here. So here's our vertex, 20 and 800. And we draw in our parabola. So here is a sketch of your graph. And just remember that you should label your axes. Okay, so area and width. Get your three or 4 points, depending on what your parabola is going to look like on your graph. And here's your sketch, and you are done. So that concludes this question. Now, the second question on our second page is similar. Oh, hang on, before we go anywhere, let's do the domain and the range for this, okay? Now, if you go back to your graph, and you look at what your x-coordinates could be, they can go anywhere from 0 to 40, okay? So our domain, using set notation, and remember our variable for the domain is the width, so w, and our values for w are between 0 and 40. And our range, if you take a look at the graph, go from 0 up to 800. Okay, so your range is area, so A, and between 0 and 800. We will now consider the domain and range for this situation. And the domain and range will represent the graph, not what happens in reality. Okay? So our domain, well, we're using w as our variable. And as you can see, we can only have values from 0 to 40. Now, theoretically, 0 is not possible because you can't have a 0 width. Okay? So that's what I mean by the domain will just represent the graph. It doesn't represent reality because in reality you can't have 0 for a width. Okay, and for your range, we're using the variable a. And according to our graph, we are going to go from 0 up to 800 because that's our largest possible lot. Okay, and once again, you can't possibly have 0 area, so technically you shouldn't include this as part of your range, but like I said, your domain and range are going to represent the graph. Alright, our next problem is very similar to this one. If you'd like, try it on your own, and so pause the video and do it on your own and then come back to it and see how you did compared to what I put on the screen. So what if the rectangular lot is fenced on all sides with partitions inside? The total fencing outside and inside is 200 meters. What is the largest possible lot? Once again, largest possible lot refers to area, and this is what we are maximizing. And because we know that we have 200 meters of fencing, this is your perimeter. And note, the rectangle does not have to be evenly partitioned. So these two partitions inside the rectangle do not have to be spaced in such a way that your 3 areas will be even. Now, this diagram is different from your other one for 2 reasons. One, you don't have a river bounding one side of your property, and you have partitions this time. So when we go to assign our variable w for the width, notice we've got 4 widths. You've got the 2 that form the rectangle, and then you have the 2 that partition the inside of the rectangle. So we've got a width, and a width. No river on one side of our property now, our lot, so we're going to have 2 L's for length. So when we go to write our supporting equation, the perimeter is equal to 4W plus 2L. And we know the perimeter is 200 because we've got 200 meters of fencing. So we will substitute that in. Okay, and once again I'm going to solve for length. Okay, so that means that the 40W has to go to the left. It becomes negative. And I'm going to divide everything by 2 so I can isolate the length. And that gives me 100 minus 20W. So my main equation then, I am going to let W be the width, and I'm going to let 100 minus 2W be the length. Okay, so remember that your width and your length should be expressed using the same variable, okay, and in this case I chose W. So our formula for main equation is area of a rectangle, so length times width. Don't know what the area is, but we do have an expression for the length, which is 100 minus 2W, and my expression for the width is W. I will expand my W and put my formula in standard form. So that means that my W squared term should be first. So W times negative 2W is negative 2W squared. And then W times 100 is my second term at 100W. So here is my formula that should calculate the maximum area of this lot. Now, because I am going to be looking for the vertex, and I'm going to be using the vertex formula, I need to know what A and B are. So I go back to my formula. A is negative 2, and B is 100. And just remember, X in this problem is my variable W, so I'm going to replace X with W. And B is 100, so negative 100 over 2 times negative 2. And that gives me negative 100 over negative 4, which gives me 25. So I know that my width is 25. Okay, so if we go back to the problem, this time they just want you to find the largest possible lot. So that means that we're looking for area. And in this particular problem, I don't have to find the length to get the area. I can just use my area formula here, the new one that I came up with. Okay, so the area is negative 2W squared plus 100W. Okay, so let's find out what the area is. I know that W is 25, so I will substitute that in for W. And when I do the math, I get 1250. And so my vertex then is 25 and 1250, okay, where the 25 is the width and the 1250 is the area. Okay, so the largest possible lot is 1,250 meters squared. Now, just remember, if you want to check this vertex, you can get your graphing calculators out, put the formula in, set up your window settings, and determine what the vertex is. Okay, so this concludes section 3.2.